So today we're going to look at how to solve equations that involve matrices. So if we look at this first example, we got a matrix minus x equals another matrix. And again, notice x is capital. That means x is a matrix. So we're looking for a matrix that we subtract from that first matrix to get this second matrix. Well, if you don't know where to start, if you're having a difficult time at starting problems, equations that involve matrices, here's a little trick you can do. Let's just take this first matrix and let's just call that first matrix 8. And let's call it the second matrix, you just make up any number, 12. So basically, if you can solve this equation, 8x minus 12, that will help you solve this equation over here. But with matrices, there's only two things that we want, only two operations that we want to use, add and multiply. We don't want to subtract or divide. So with matrices, we're going to avoid subtracting and dividing. We're just going to add and multiply. Okay? So let's try to do that with the green equation. Let's try to solve the green equation by using only addition and multiplication. So to solve the green equation, we could, if we want to use addition, we could add -8 to both sides. And then 8 plus -8 cancels out. We get -x is equal to 12 minus 8 is 4. Now the next step, if I can only use addition and multiplication, I want to get the x by itself. Well, there's a -1 here. What I could do is I could multiply both sides by -1. So what we end up with is x is equal to -4. So now we know how we can solve that matrix equation. It took us 2 steps to solve the green equation. So it's going to take us 2 steps to solve the matrix equation. Well, the 8 represented this first matrix here. What did I do to get rid of the 8? Added its opposite. So what we're going to do over here, remember we only want to add and multiply. So I'm going to add the opposite of this matrix. It's called the additive inverse. I'm adding the additive inverse of this matrix. So all I do is I just change the signs of all my elements. And just like a normal equation, whatever you do to one side, you gotta do to the other side. So if we add the additive inverse on this side, we're gonna add the additive inverse over here. So we're gonna add the same matrix over here. So these will cancel out. And I get -x is equal to, well, let's add our corresponding elements. 0 plus -1, -1. 8 plus -3, 5. 1 plus -1, 0. 9 plus -2, 7. Trying to solve for x. I got -x. Now I need to get rid of the negative sign on the x. How do we do it over there? We just multiply both sides by -1. So I'm going to multiply both sides by -1. So I'm using a scalar multiple here. We'll multiply both sides by -1. So on the left side, I just get x, and then I'm going to take -1 times each of these elements in my matrix. So x is equal to 1, 0, -5, -7. That's our answer. All right, let's look at another example. Again, if you don't know where to start, what I recommend you do is just take your matrices, and just replace them with a number, any random number. So I'm just going to put 12 here. We can put, 20 over here. What will we do to solve this black equation? Again, we only want to use addition and multiplication. All right? Let me slide black equation over here. Let's work this black equation out. So if I can only use addition and multiplication, I'm going to have to add the opposite of negative 12 to both sides. I'm adding the additive inverse. So that cancels out. I get negative 3x is equal to 20 minus plus negative 12 is 8. Now, again, we don't want to divide. How can I get rid of negative 3 without dividing? I could multiply both sides by the inverse. The multiplicative inverse. It's also called the reciprocal. So we get x is equal to negative 8 thirds. All right, so that's what we want to do. Now we know how to solve this matrix equation. Because basically, if you can solve the black equation, you can solve this matrix equation now. So the first step is going to be to add the additive inverse of this matrix. So we're going to change the signs of all my elements. I'm going to add that to both sides of my equation. So we have negative 3x is equal to 10 plus negative 7, 3, negative 19 plus negative 2, negative 21, 0 plus 0, 0, negative 18 plus 3, negative 15, 8 plus 1, 9, and then 10 plus negative 4 is 6. Okay, what did we do to the black equation once we got to this step? We multiply both sides by negative 1/3. So that's what we're going to do here. We're going to multiply both sides by negative 1/3. So here's my answer. X is equal to the following matrix. So I'm going to have to take negative 1/3 times each element of this matrix. So we get negative 1, 0, negative 3. And then on the bottom we'll have 7, 5, negative 2. So x is equal to this matrix right here. All right, one more example. This one's a little different because the variable is not a matrix. The variables are elements. Notice where the variables are located. They're located inside the matrix, and they're lowercase letters, not capital letters. Okay? The only way two matrices can be equal is if they have the same dimensions and the same elements. All right? So both of these matrices are 2 by 2 matrices. So the only way they can be equal is if the corresponding elements in both matrices are the same. Well, if you notice here, in this spot right here, in this element right here, that's in row 1, second column, is 5. If you look at the element that's in the row 1, second column over here, is also 5. Okay? And look here. We got negative 3 and negative 3. They're both equal. So what you do to solve this is just take this element here, x squared. What should x squared equal? It should equal 81. So set x squared equal to 81 and solve this equation. So to solve this equation, if you think back to Algebra 1, we're going to take the square root of both sides. And whenever you use this is called the square root method, you always got to put plus and minus on your answer. What's the square root of 81? 9. Remember, the original equation was x squared equals 81. So the solutions are 9 and negative 9 because 9 squared is 81. Also, negative 9 squared is 81. So x is equal to positive and negative 9. Now, what should I set y squared equal to? I should set the y squared equal to negative 4y. So y squared equals negative 4y. We need to solve this equation. Well, it's been a while since we've done something like this. This is a quadratic equation. So was the first one. First one was a quadratic equation. That's why I had two solutions. So to solve this one, what we're going to do is we're going to add 4y to both sides. So now I got y squared plus 4y is equal to 0. And then what I'm going to do is I'm going to try to factor the left side. Well, when it comes to factoring, the first step is to look for a greatest common factor. The greatest common factor of these two terms is y. So I can factor out a y. So I'm going to have y times the quantity, y plus 4, is equal to 0. So now, what we can do, since we have y times this, and that's equal to 0, that means one of these is equal to 0 on both of them. So what we do is we set y equal to 0 and y plus 4 equal to 0 to find our solutions. So one of the solutions is y equals 0. The second solution would be, well, subtract 4 on both sides, y equals negative 3. Now we'll finish.